Welcome to Math is Beautiful. In this video, we meet the Fourier Transform, the discovery that every signal, music, speech, images, is a sum of pure waves, and the machine that finds the recipe. What does a Fourier transform actually do? It answers one question: what is this signal made of? Here is our signal, wiggling in time. A signal is just a number changing through time: air pressure at your eardrum, voltage on a wire. Drawn out, it can look hopelessly messy. The Fourier transforms claim every such mess is secretly a sum of pure waves. See it in reverse first. Take 3 clean sine waves, a slow one, a triple speed 1 at a third the strength, a 5 times 1 at a fifth. Add them point by point, and a squarish wave appears. Simple ingredients, complicated-looking total. The Fourier transform runs that backwards. Hand it the messy total, it returns the ingredient list, which frequencies how much of each. Signal in, recipe out. The recipe is a graph called the spectrum, frequency along the bottom, and each height says how strongly that pure wave is present. Our squarish wave. 3 spikes at 1, 3, 5, heights 1, a third, a fifth. How does it find them? Multiply the signal by a probe wave and average. If that frequency lies inside, products reinforce large average. If not, ups and downs cancel to 0. Sweep all frequencies, that is the transform. And that is the superpower. Hard problems on the signal become easy on the recipe. Remove a hum, delete one spike. Compress a photo, keep the big spikes, drop the tiny ones, that is JPEG. This is important. Now let's look at an application of this concept. A signal that is 3 sine t plus sine 4t. What does its Fourier spectrum show? Read the signal as a sum. 3 units of the slow wave, frequency 1, plus 1 unit of a faster wave, frequency 4. So its spectrum needs no computation at all. 1 spike at frequency 1, 3 tall, 1 spike at frequency 4, 1 tall. Everywhere else, 0. Now use the parked superpower. Call the fast wiggle noise, delete its spike in the recipe, rebuild the signal, and only the smooth 3 sine t remains. That one edit is exactly how real noise filters work. So every sound you have ever heard was a chord of sines, and the Fourier transform is how mathematics listens. Thank you for watching. If you found this video helpful, do like it, subscribe to Math is Beautiful, and share it with your friends.